All right, today we're going to be looking at section 6.2, polynomial division and the division algorithm. The objectives are to construct polynomial with given zeros, polynomial long division. We're going to use polynomial long division to solve applications. We're going to use synthetic division and the remainder theorem to evaluate polynomial functions. And then we're going to use synthetic division to divide polynomials. Majority of this, we're going to be using polynomial division, either synthetic or long division, to solve most of these problems. So here are the, I guess, the mathematical definitions. Some of them are kind of complex and not so easy to understand unless you already know what's going on. But I will at least point out the symbols that you will see. So px might just stand for the polynomial, and then you're going to be dividing that polynomial. The solution to that problem, whenever you divide two terms, you get a quotient. So the quotient is the qx, that's just the part here, and then you will have your divisor and your remainder. So like it says, if you multiply the quotient times the divisor plus the remainder, it should be equal back to what you started, your dividend. But for the most part, they're just going to be showing you some function divided by some term. It might be a linear factor. It could be something else. But you're going to be dividing a polynomial, and you'll get your quotient, and then you'll, if you have a remainder, you will put that remainder over the divisor for the last part. So it's easier to see that actually in practice. So let me kind of walk you through, I guess, an example that's provided here. So they have video showing you how to solve it. Here's your polynomial. They're dividing by x plus 6, and they're just kind of explaining the process here. So you would try to figure out the first term here and the first term here. What do you have to multiply this first term by to get it to equal this first term? So x times x will give you x squared. So that's how you figure out that. And then you multiply both terms by x, and then you write that down here, and then you subtract. And so this is the process. And then if you don't have a remainder, this is your quotient, x minus 4. That's your answer. And then 0 over your divisor would just be 0. So I will do a lot of examples like this for you. Here are the steps. Arrange it in descending order. Divide the first term into the dividend of the first term, and you will repeat that process. You're going to multiply the entire divisor by that term. Write it beneath the dividend so the terms line up. Subtract. Bring down the rest of the original dividend, forming a new one, and then just repeat that process until you get complete. So I will actually walk you through that process. So here are some more examples. Long division is one that was easier for me to understand, but I don't like it as much now. I like synthetic a lot more, and we'll see that one coming up next. So here's a little warning. Please do read through and understand that. And then we have synthetic division. No, this is still showing long division. Sorry, I just saw the imaginary number. So just another example for you there. And then synthetic division. So synthetic division is doing the same as long, except it does not require all the variables. In its process, you will just use the coefficients of those numbers, the -2, the 8, the -9, the 7 over here. And then you would use the linear factor set equal to 0 and find out that that number is 2, and that's what you're going to put in your box. And that process is you bring the first number straight down. You will multiply this 2, whatever's in the box, by that first number. You write your result above the line, and then you would subtract. So if you do 2 times -2, you would get a -4. You would subtract those and get a 4. Then you would do 2 times 4, write its result here. That would give you an 8. And then 9 minus 8 will give you a -1. Or -9 plus 8 will give you a -1. and then you would do 2 times -1, write its result here, subtract, and you would get 5. Then you had to add back in your variables, which is just now showing you that step. I don't know why they didn't show it here, but here are the coefficients. So you were dividing by a single x. So since you started with x to the third, you will now reduce your degree by 1. So instead of x to the third, you would have x squared. So with this term, you would start x squared, x, no x, and then this is your remainder. You need to know how to write that as well. So the negative, if you compare this, -2x squared, that would be your x squared term, and then a positive 4x, and then a -1, and then you have a remainder of 5. And you would divide that over your divisor. Here are those steps. You have a divisor, you're going to write it down. You're going to write the leading coefficients on the bottom row, multiply C by the value represented in the bottom. Place the product in the next column. In the second row, add the values in this column, giving a new value on the bottom row. And then you're going to repeat that process until it's complete. The numbers on the bottom row are the coefficients plus the remainder. It says note, first term of the quotient will have degree 1 less than the first term of the dividend. So that is saying whatever you have, which is x to the third, you're going to start with x squared and just count down from there. But I will also show that process. So this is a little history of how synthetic division was birthed, 1804. And then just here are some more examples with synthetic, and I'll explain these process with the missing terms as we practice them in Hawks. And then some more. So when you have the imaginary number, it gets a little bit more challenging, but still solvable. And that's pretty much it. So just here's a few more examples. This is writing polynomials, but again, I will show you that. And then of course you have these examples to look at as well. So anyway, again, this is a little bit challenging, but I'll do my best to walk you through all of this so that you get a good understanding. So with that, let's jump over to Hawks.